Hi class 9 students, welcome back. So this is our lecture number 7 of the chapter motion. So guys, here we will be solving few numericals based on acceleration and equation of motion. So these numericals are of type B and the formula here we will be using are first one for finding out the acceleration, that is A equal to final velocity minus initial velocity by time taken. So A equal to V minus U by T. And the second formula is S equal to ut plus half at square. So for this one is finding out the distance. Here S is the distance and this is the second kinematical equation. And the third formula is V equal to U plus AT. And this is the first kinematical equation. Okay, so now see question number 1 and this should be 1, alright. A car accelerates uniformly from 18 km per hour to 36 km per hour in 5 seconds. Calculate the acceleration and the distance covered by the car in that time. Okay, now what are the given values here? So the initial velocity is given, that is u equal to 18 km per hour. Now it is given in 18 km per hour. Kilometer per hour, right? And we have to convert it into meter per second. So convert it 18 into 5 by 18. So cancel it and we will get 5 meter per second, right? And the initial velocity is 5 meter per second and the final velocity, that is v equal to 36 km per hour. So convert this also into meter per second and after converting it we will get 10 meter per second and the time t is 5 seconds. Okay, so what we have to find out? We have to find out the acceleration, that is a, and the distance covered, that is s. Okay, so here the formula we will be using, as you already got that for finding out the acceleration, it is a equal to v minus u by t, that is the initial velocity minus final velocity by time taken. And for finding out the distance covered, we will use the second kinematical equation, that is s equal to ut plus half at square. Okay, so now solve it. For first we will find out the acceleration. So a equal to v minus u by t. Now put the value and we will get a equal to 1 meter per second square. And see students, don't forget to write the unit, alright. Now we will find out the distance covered. So write the formula s equal to ut plus half at square. So we know that initial velocity is 5 and the time is also 5 seconds. So 5 into 5 plus half into acceleration is 1 into and time is 5, so 5 square. Now do the calculation. This is easy calculation. So we will get the distance covered s equal to 37.5 meter. So the answer is the acceleration of the car is 1 meter per second square and the distance covered is 37.5 meter. Clear everyone? Next we will see question number 2. A bus starting from rest moves with a uniform acceleration of 0.1 meter per second square for 2 minutes. We have to find out the speed acquired and the distance traveled. Okay, so here what are the given values? Initial velocity equal to 0 meter per second, right? Because the bus just started from rest and that is why the initial velocity, that is u equal to 0. And the acceleration is given, that is 0.1 meter per second and the time is in 2 minutes. So convert it into seconds. So we will get 120 seconds. Now what we have to find out? We have to find out the speed acquired. Okay, that means the value for v and the distance traveled, that is s. So the formula here we will be using are, for finding out the speed, we know that it is v equal to u plus at, which is the first kinematical equation, right? And for finding out the distance traveled, you already know, I guess. Yes, it is the second kinematical equation, that is s equal to ut plus half at square. Clear? Now let's solve it. So we will find out the speed first, v equal to u plus at. Now put the values accordingly. So we will get, after calculating it, v equal to 12 meter per second. And then we will find out the distance traveled, that is s equal to ut plus half at square. Now put the values. So we will get s equal to, okay, do this calculation by yourself. So it is half into 0.1 into 120 square. So cancel it and we will get s equal to 720 meter. Okay, so the answer is the speed of the bus is 12 meter per second and the distance travel is 720 meter. I hope everyone is clear, because these are just formula based questions. All you need to do is just put the formula and then put the values. After that, do the calculation and you will get the answer. Okay, next we will see this question. A racing car has a uniform acceleration of 4 meter per second square. What distance will it cover in 10 seconds after that? Okay, so here the acceleration is given, that is 4 meter per second square, but before that, see here the initial velocity is equal to 0 meter per second, because the racing car has just started from rest, right? And that is why the initial velocity is 0, and the acceleration a equal to 4 meter per second square, so time is 10 seconds, right? And we have to find out the distance travel, that is the value for s. So the formula here we will be using is the second kinematical equation, and you already know this, right? And that is s equal to ut plus half at square. So let's solve it now. S equal to, so it is the initial velocity, it is 0, so 0 into time is 10 seconds, so 0 into 10 plus half into 4 into 10 square. Calculate it and we will get the distance s equal to 200 meter. Okay, so the answer is the distance covered by the racing car in 10 seconds is 200 meter. So this is another formula based question. It is very easy. Try to pause the video and do the problem by yourself, okay, by seeing the question. Next we will see this question. The brakes applied to a car produce an acceleration of 6 meter per second square in the opposite direction of the motion. If the car takes 2 seconds to stop after the application of brakes, calculate the distance it travels during this time. Okay, now you might be thinking that this question is little bit laggy or tricky, but it is not. If you have not understood, try to read the question twice or thrice, okay, and you will understand it more clearly. So read it again, because it will be very clear to you. The brakes applied to a car produce an acceleration, that means acceleration is given this much in the opposite direction of the motion, okay, and the car takes 2 seconds to stop after the application of brakes, so time is also given. Now we have to find out the distance, that is calculate the distance it travels during this time. Clear everyone? Now what are the given values? Acceleration equal to minus 6 meter per second square. See here, what is the why is the sign minus is here? Because the brakes applied in the opposite direction of the motion, right? And this is why the minus sign is applied in the acceleration, and the time taken is 2 seconds. So the final velocity v equal to 0 meter per second, right? And we have to find out the initial velocity, that is u equal to how much, and the distance traveled, that is s. Now formula here we will be using for finding out the initial velocity, that is v equal to u plus at, which is the first kinematical equation. Then for finding out the distance, you already know, that is s equal to ut plus half at square. Now let's solve it. So first we will find out the initial velocity, v equal to u plus at. Therefore we know that the final velocity v equal to 0, so 0 equal to u plus minus 6, that is acceleration, and the time is 2 seconds. So we will get u equal to 12 meter per second, and then we will find out the distance. So put the value accordingly. S equal to 12 into 2 plus half into minus 6 into 2 square. Then calculate it and we will get s equal to 12 meter. So the answer is thus the car will move 12 meter before it stops after the application of brakes. Clear everyone? And now we will be solving few numericals based on uniform circular motion. So these numericals are of type C, and the formulas we will be using speed equal to circumference of the circle by time, and the speed equal to perimeter of field by time. So now see question number 1. An artificial satellite is moving in a circular orbit of radius 42,250 km. Calculate its speed if it takes 24 hours to revolve around the earth. So now see, this is our earth where a satellite is revolving around it, and the radius is 42,250 km, and the time taken by the satellite is 24 hours. So now write what are the given values. Radius of the circular path, that is r, equal to 42,250 km, and the time taken to complete one round, that is t, equal to 24 hours. So we have to find out the speed. Okay, now what is the formula for finding out the speed? Yes, it's very easy. It is speed equal to distance by time, right? Okay, so here the distance is the circumference of the circle, that is 2 pi r. Now let's solve it. So speed, that is v, equal to distance, we know that it is 2 pi r by t. So now put the values. 2 into 22 by 7, that is the value for pi, into 42,250 by 24. Now cancel it and do the calculation. So we will get v equal to 11 into 21,125 by 7 into 3. So v equal to 11,065 km per hour. Okay, and the answer is the speed of satellite equal to 11,065 km per hour. I hope everyone is clear. Yeah, this is just formula based question. Now see question number 2. An athlete completes one round of a circular track of diameter 200 meter in 40 seconds. What will be the distance covered and the displacement at the end of 2 minutes 20 seconds? So see, this is an athlete where he completes one round of a circular track and the diameter is 200 meter. So the radius will be 100 meter, right? And the time taken to complete that one round of a circular track is 40 seconds. So now write the given values. Diameter is given 200 meter. Therefore, radius r equal to d by 2. So we will get 100 meter. And the time for one round, 40 seconds. Now we have to find out the distance covered and the displacement at the end of 2 minutes 20 seconds. Okay. So distance after 2 minutes 20 seconds and the displacement after 2 minutes 20 seconds. So now solve it. First we will find out the distance covered in 40 seconds. So in 40 seconds, one round of the circular track equal to circumference of circle. And we know that circumference of the circle equal to 2 pi r, equal to 2 into pi into 100, so 200 pi meter. And the distance covered in 1 second equal to circumference of the circle by 40. So 200 pi by 40. Now cancel it and we will get how much? 5 pi meter. Okay. And now see the total time athlete run equal to 2 minutes 20 seconds. Right. So now convert it into seconds and we will get 140 seconds. Now see here the distance covered in 140 seconds equal to 5 pi into 140. Right. So we will get 700 pi meter. And now convert pi into the value. So 700 into 22 by 7. Now cancel it and we will get 2200 meter. Okay. Now we will find out the number of rounds athlete runs equal to distance covered in 140 seconds by distance covered in 40 seconds. Okay. So equal to 700 pi by 200 pi. Now pi will get cancelled. So we will get 3.5 rounds. Okay, so 3.5 rounds equal to 3 full rounds plus 1 half round, right? This is this. Okay, so see here the person is at the opposite side of the track after 3.5 round, as you can see here. So here the displacement equal to diameter of track equal to 200 meter, right? This is the displacement, so it is 200 meter. So the answer is after 2 minutes 20 seconds, the distance covered in 2200 meter and displacement is 200 meter. I hope everyone is clear. Next we will see question number 3. A farmer moves along the boundary of a square field of side 10 meter in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds? Okay. Now see here, this is the boundary of a square field of side 10 meter. Okay. And here the farmer moves along the boundary of this square field of side 10 meter in 40 seconds. So the time taken is 40 seconds. So what will be the magnitude of displacement after 2 minutes 20 seconds? Now first write what are the given values. Since here the side of the square field equal to 10 meter and also perimeter equal to 10 into 4, we will get 40 meter, and the time for one round equal to 40 seconds, and we have to find out the displacement after 2 minutes 20 seconds. And now let's solve it. Okay, first see the distance covered in 40 seconds equal to how much? So in 40 seconds the farmer covered one round of the field, right, equal to perimeter of the field, so it will be 40 meter. Now distance covered in 1 second equal to perimeter of field by 40 equal to 40 by 40, so we will get 1 meter. Now the total time farmer moves equal to 2 minutes 20 seconds, right? So convert it into seconds and we will get 140 seconds. Then the distance covered in 140 seconds equal to 1 into 40, so it is 140 meter. Now see the number of rounds the farmer completes. Okay, so we have to find out the number of rounds the farmer completes equal to distance covered in 140 seconds by distance covered in 40 seconds. Now distance covered in 140 seconds equal to 140 and distance covered in 40 seconds equal to 40. So we will get 3.5 rounds. Now 3.5 rounds equal to 3 full rounds plus 1.5 round, right? And here the person is the opposite side of the track after 3.5 round. So displacement, that is AC equal to, this will be the displacement. AC equal to, now take the root over, this is coming from the Pythagoras theorem, okay? So root over AD square plus DC square, AD square plus DC square, and we will get root over 10 square plus 10 square, so it is root over 200. So we will get a displacement AC equal to 10 root over 2 meter. So the displacement of farmer after 2 minutes 20 seconds will be equal to 10 root over 2 meter northeast from initial position. Okay, I hope everyone is clear. You might find this question little bit tricky or something like that, but don't worry, this is also another easy question. You just practice it by yourself. Okay, so this is all about lecture number 7. Thank you, students.